And I noticed myself just really enjoying assembly language. It's an open source project from the get-go, never commercial, but it just kind of exploded in popularity from there. Like my cube engine could be used for like the interiors, because everybody had a really great landscape engine that they were working on for what ended up becoming Far Cry. Something wonderful that I hadn't thought of is like, I don't want to be the person that has to think of all the possible gameplay that happens in my game. I want, my users to be able to take it as far as possible. But what if I just send every modification as a network message along with the rest of the multiplayer? You often get into like lots of nested ifs and whatnot. So guard is a way to basically do something similar to an if, but instead of it being indented, it basically is like an assert where it just cuts.
They're always dangerous to do, but we're gonna try.
I'll just look the other way when you're doing that.
Hey, what's going on, folks? It's Mike here, and today I proudly present to you a conversation that I've had with Wouter van Oortmerssen. He's a game programmer, game engine programmer, programming language designer, compiler developer, and tool developer, and we're going to get into all of this, talking about many of the different programming languages and tools and game engines that he's built along his career. And we're going to lead up to what he's currently working on, which is the Lobster Programming Language, which he's using at his own game studio, VoxRay Games. All this and more we're going to cover, and we're even going to dive into talking about the Lobster Programming Language with Wouter himself. So I'm very proud of this conversation. There's lots of insights for software developers, entrepreneurs, programming language designers, game engine programmers, and more in this conversation. So sit back, relax, and enjoy this conversation with Wouter van Oortmerssen. It's a real pleasure this evening, folks, to have Wouter van Oortmerssen with us today, who has worked on a variety of projects that we're going to get into, ultimately ending with talking about your Lobster programming language, as well as other programming languages. So, Wouter, thanks so much for being here. How are you doing today?
Very good, very good. Thank you for having me.
Excellent. So, I have to actually start off with a little bit of a story, because I thought it was great when we had gotten connected, and I looked through some of your history that you had worked on something called the Cube engine many years ago, and actually a Cube 2 engine, both which are, you can find the source code and are active and well documented. But I just remember trying that out when I was a kid and sort of getting my start. And it was just a beautiful engine, very simplistic and elegant.
Thank you.
I couldn't believe that you are also behind the Lobster programming language as well. So, so it's a real honor here. We'll get back to the elegance of some of your projects here, but I actually want to start off by just surprising you with a piece of code here.
Okay.
So I'm going to go ahead and share my screen here, as one does. So just give me one moment to do that. But I want to show you this code here, and it's code you haven't seen before by any means.
Okay. Oh gosh. Oh my gosh. Okay, this is from the Obfuscated C Competition or something.
Sure is. Yeah, if you know the URL here. And this is one by one of our previous guests here, Walter Bright here, and you can see some of the names of other folks here in industry and so on.
Who of smart people.
But why I'm showing you this is not because I want us to read this today. In fact, I don't want anyone to read this or to take this serious. This is for a competition. But I did want to go to one of your tools here that I'll screen share briefly, called Sloppy. And can you tell me just a little bit about the origins of this tool? I was very curious about where this came up.
So this you'll see in like a lot of my projects. There's a lot of my projects that have something to do with a big chip on my shoulder, and that chip on my shoulder is all about like how you program and style of programming. And I'm a huge fan, I've always been, of like a bottom-up style of programming, where basically your code grows as you develop it, and you keep it in like what I like to call like a normal form, like a form where there's hardly any repetition. And people call it DRY typically, but that's not quite the same. And I've thought a lot about like how, as a programmer, you can achieve this form, how difficult it is to keep refactoring things, to keep your code in good shape. And I've done various projects along those lines. Sloppy is a simpler one. Another project of mine is called Restructure, which actually tries to refactor an entire code base, which is totally crazy. Sloppy is a very simple tool because it basically tries to see how much repetition there is in your code in a simple way by doing it on a token level. But it is able to match like segments of code, even if you made some modifications in them. So you copy paste some code and then you make a couple of modifications in them. It's still able to detect that as like a duplicate that maybe you should have like refactored. So then it throws out a score over your entire code, just giving you an impression of like how bad your code is doing. But the cool part is it throws out a list of like the 10 worst points in your code. And that's meant to be like almost like a game, like, you know, like a quest list is like if your main quest, your side quest is like, oh, what I'm going to do next. And you're basically constantly refilling quests and solving these quests. And I wanted this to be like fun for people to use because I wrote this at a time that I was teaching at a game development school, the Guildhall. And I was actually, big evil laugh. I was going to try this out with the students. And I did basically ran this on all their code. And, you know, some students would get worse score than others. And then we'd spend the whole day working on improving the code. And then we'd see the scores again at the end and see like who had the biggest improvement. And just kind of really gamify the idea of like how to build good software. Nowadays, I wouldn't necessarily agree that like, you know, just doing DRY is like, you know, the best way towards, it's much more complicated than that. But it's certainly an aspect of it. So,
yeah, I love that idea of one gamifying, you know, how much somebody improves their code. So that definitely goes towards, you know, thinking creatively as a teacher, which I love as a, you know, teacher myself. But I think this is also kind of an interesting tool. Is this something that you at some points have integrated into like continuous integration or checking for sloppy code, or are there other tools we might want to use for that?
I've never taken it that far. It's always been run manually, and I've run it on my own code base at various times to see like, hey, I'm almost out of curiosity, right? It's like, I wonder what it's going to find. It's like, oh, yeah. Oh, that's generated code. We can either exclude that, right? Because obviously it's going to look crap. But yeah, I thought it's like, I've never had the energy to do this myself, but certainly this would have been great to have integrated into like an IDE where basically you can always point you or maybe even colorize or do something like, hey, by the way, this big block of code or somewhere, it also appears somewhere else, and maybe you should do something about it.
Yeah, so I'm very curious. You know, maybe we should rewind even back a little bit before we dive into some projects. And I wonder if this sort of aesthetic or love of code, I mean, is this something that you've always had? I mean, take me back to the first time you were learning how to program. Do you remember what that first program looked like or what language you were using? Let's go ahead and rewind way back.
Yeah, I think that's related in the sense that I've always been motivated by programming for its own sake and interested in that. It's never been quite, that's also why I got into programming languages, because if you really care about the code itself and what kind of tool it is for you, then naturally you start thinking about like why you might want to develop your own programming language. So going way back, my first programming experience started on a computer called the BBC Micro, and that happened to be the computers we had at school at the time. I think I was 12 or something at the time. Yeah, those computers like actually was pretty powerful in terms of what kind of basic they had, more powerful than say the Commodore 64 and whatnot I got afterwards. But one big issue with my first programming experience were that we could never save anything. So my first programming experience were very much geared towards trying to develop things that I could then at the end kind of remember how they were, and if I got back onto the computer, I could quickly type them in and basically continue, which is a very strange method developing. So programs always stayed small and simple, but certainly interesting.
Do you remember some of those programs you were writing? Were you writing games or trying to just build little functions, or what did those sort of exercises look like?
They certainly were all very simple, so no full games. One I can remember quite fondly was like what's essentially like a little music program, because it was very easy to do. Like you would just get keys from the keyboard and just kind of do some stuff to them and then pipe them into the synthesizer or the computer. And that was just a was very easy, a couple of lines to be able to type in and experiment with. Yeah.
I love that. I love hearing about these early projects because folks are always trying to figure out what to build, and beyond what's interesting, sometimes they can take inspiration from folks like you. So music programs, simple programs, great. So sort of take me next, what's on your programming journey where you're doing stuff with BBC Micro, and then do you go to the equivalent of like a high school or university in the Netherlands, or what's the sort of next step?
Yeah, after that, I got my hands on Commodore 64 and Commodore 16, which are very similar computers. But that was all kind of at home at that time. So that was not school driven. And that's when I, for the first time, sort of developed. Particularly in the Commodore 64, I got into making some games. In particular, I remember one of my early games was a lawn mowing game, because basically you couldn't refresh like the whole screen at once. So it was kind of nice to be able to have a game that modifies the game world kind of as you're playing. And I thought that the lawn mowing was fun. So, and then later I got into my first programming languages. At first written in BASIC, and then generating assembly or machine code at the time. So directly poking bits and bytes into memory kind of thing. And then later even doing that kind of stuff, but then directly written in machine code as well. So I attempted to make my first operating system at a time, but it didn't get super far, by making like a graphical user environment and things like that.
And this was in BASIC you're programming at this point, or had you moved on to C or some other language?
No, I didn't have available any C or such compilers on these platforms. So it was mostly BASIC. The Commodore 16 was interesting because you could hold on a button and it would jump down in the machine code monitor, where you just kind of directly code in machine code. So you type the assembly and would get assembled on the spot. And that was kind of my first introduction to kind of lower level programming. But yeah, these machines don't have C compilers available, so that came later.
Now, I've always wondered this. Do you think having to work at that level early on and looking at assembly code, has that provided you advantages in your career to sort of think about how the machine works? I mean, should folks who are learning programming now maybe think about assembler or building their own assemblers? I mean, what do you sort of, from both your professional and teaching standpoint, have you had this observation? I've kind of had that myself, but I don't know if you'd agree.
Yeah, so I feel it's been extremely helpful because I learned, being a bits and bytes kind of person like early on, and the knowledge that I gained through that has never changed. I mean, now we have 64 bits all in one go, and then we had 8. But other than that, it's exactly the same stuff. All the knowledge I've gained, I've been able to carry through the years. And, I've worked on numerous compilers and other low-level systems and game engines, and just being super good with bits and bytes has been incredibly helpful. Also feel strongly that I would not recommend anyone to actually use assembly as a programming language nowadays. But one thing it does, if you do teach yourself assembly to start with, it makes every layer above there so much simpler. So I feel when I first learned C, it's like, oh my gosh, all these stars and ampersands, but it's like I just translated in my mind to what the pointers were doing underneath. I had a very good understanding of pointers and memory from my assembly days, and it really kind of shrunk down the language of C to almost nothing. It was just syntax. Whereas someone that comes to C not having an assembly, it's like you can get like lost, like what it means to have all these different kinds of pointers and whatever. And at the end, it's just a big array of bytes and integers that point to it. It goes to nothing. Then C++ becomes simpler because your kind of C is very transparent to you. Now you go into, like, say, a garbage collection language like Java or something like that. Now that becomes simple because you can just kind of understand how that's implemented, and everything from there out. Whereas people that start learning their journey, right, first learning Python, and then maybe graduating to, say, Java or C# or something, and they have all these kind of hurdles to overcome where they're kind of confused. Well, what's it actually doing? What does it mean when I do this? Like, why is my program slow because I'm generating so many garbage objects every frame or something like that? And it all becomes like complete mystery. When it worse is maybe a language like JavaScript, which, you know, sometimes is incredibly slow and sometimes is actually incredibly fast because, you know, people like the V8 team, they, you know, do absolute magic with certain patterns of JavaScript. And you as a programmer, you're just making stuff and you just have no idea what's going on. And so to me, it depends really, like if you're a beginning programmer, you're gonna ask yourself, like, how far do you want to get with this? If you're the kind of person that says like, well, I'm just kind of dabbling in it, I just want to see some things move on screen and I'm probably not going to make this my career, fine, use Python. It will be great. You'll have a lot of fun. But if you're saying is like, one day I want to be the person to, you know, develop new programming languages or write entire new 3D engines from scratch or something like that, you're probably doing yourself a disservice starting at the high end and moving towards the low end. You probably want to go the other way around.
Yeah, I love that. I love that. So kind of early on in your career, I mean, can you remember sort of major aha moments? I mean, was it that jump from, you know, going from, say, assembly to C and saying, oh, I can, you know, see what's going on in the machine? Or what kind of stood out early on, let's say college, where you saw something really cool and you just knew, you know, computer science was for you, and this was going to be your path forward for the next, you know, for your career, essentially?
I'm afraid to say that was really never a thing. Like from the early days of programming that I just told you about, like I was just so engrossed in the actual act of programming. I was so into understanding what the machine was doing and trying to use that to create my own programs and languages and whatnot. And this was all before I got to college, by the way. So when I got to college, I had already written several compilers and whatnot. So I used college time more to kind of do whatever the next thing was for me, because the actual computer science was like sometimes not, oh, it was interesting, but that certainly taught me things which I had completely skipped because, of course, computer science teaches you all these kind of more theoretical topics that you would not seek out if you're just a practical programmer. But yeah, studying computer science did not help me get on this path for sure. Yeah, like I said before, I'm really the kind of person that just digs the actual act of programming. And nowadays, you know, I kind of made games my topic kind of thing because it's kind of combines my love for programming languages with like being able to make something that other people want. One frustrating thing about, you know, having tried to build various languages along the way is that it's incredibly hard to get anyone. If you say like, I'm building a new programming language, everyone just kind of runs away. It's like, oh my God, there's one of those people. You know, it's almost, you have to almost force it on people. People do not like, people complain that there's too many new programming languages being made and there's already so many. It's such a hard time trying to learn them. So you're doing people a disservice by making new ones in some kind of way. Whereas games is the opposite. It's like, hey, I made something that's kind of fun. Everyone goes like, oh, can I try it? That looks so cool. And it's like, so it's kind of easier to make that your career, but yeah, for me, it combines both. So
Yeah, maybe there's an interesting question because I want to get into your university time and your history of languages, but maybe a question on this thread while we're here is, you know, why is it hard, like you said, to get some groups to adopt a new programming language, even if, you know, it might be 10 times better or 5 times better across every category, but we kind of, is it because of, you know, what in your opinion, why is that? Why are people only using like 5 main programming languages if you look at job listings?
yeah, good question. People are extremely conservative towards new programming language. I think there is a large segment, certainly today, of probably 90% of programmers for whom it's mostly just a job. They want to get the work done, and those people, once they've latched on, is like, okay, I know JavaScript, and just like they don't even want to hear about anything else. And there's certainly 10% of people that are a little bit more hardcore and are more interested in things. But even for them, you know, I don't think it's very difficult for a language to have a 5x advantage over over something existing. And the problem is that even for someone who's very interested in learning a new language, you have to kind of spend a lot of time with the language before it starts clicking that there's certain things that are a huge advantage to you. I mean, for example, you can name like a small example, like, Lobster has nillable types, so it's impossible to ever dereference a nil variable. And many languages have that nowadays, so it's not anything special. But to me, it's like I have so many hours of debugging saved by that feature. Like, I would never accept to ever work in a language again that doesn't have that feature. And that's just a small little part, right? And then you have a whole bunch of those kind of features that all kind of pile up to just make you several times more effective. And yeah, this kind of, if you look at programming language in their history, it always takes a very long time because so many people need to go through that process of, hey, this is really doing something for me. I'm going to try and convince other people. And then slowly projects start using it. Like now you see Rust, for example, becoming a popular programming language. It was obvious from the start that if you told anyone experienced with programming languages, like, hey, this language, it can actually do safe manual memory management without garbage collection, and it will allow you to write multi-threaded code with guaranteed no sharing issues. Those are amazing features, but it still took, I don't know, 20 years to get to this level of popularity for some things that like other programming languages really do not provide. There's stuff that Rust can give you that you go to another mainstream language and you just have to deal with all that stuff manually and just deal with the bugs. So yeah, any new cool thing that comes out of programming language, it's going to take like 20 years before people are convinced that they need to have it. It's tough.
Yeah, I tell folks 10 to 20 years, that's a young programming language, as you've echoed. So things take time, but I always think it's a competitive advantage if you're a company or a startup or game studio, if you own the language and the tools and can move faster and safer.
Yeah,
that sound like good things.
Yeah, we definitely do that. Like I use Lobster, of course, in my own company, and we sometimes run into things, and I'll just actually fix things in the language to make it better for us. It's really cool.
Yeah, so I think maybe things are going to catch on here. So we'll see what we can show folks with Lobster towards the end here. But let's go ahead and get into some of your programming language history, because at university, like you mentioned earlier, you'd done a lot of programming, so you had time to do some different projects. If I understand correctly, in 1993, you were building the false programming language. Was that one of the first projects in the timeline?
That was kind of started after Amiga E, which is a bigger project. So yeah, maybe mention that one first in terms of doing things in order.
Yeah, let's talk about Amiga E, which I understand was written in assembly,
Yeah.
if I understand correctly, and it actually quite caught on quite well. So yeah, maybe you can tell me a little bit about the history, what inspired it, and what made the language special at the time.
So yeah, Amiga E is certainly my first big language, first language that got quite far and a whole bunch of those properties. Before then, most of my compilers were implemented in BASIC, and I was very, very annoyed with like how slow and clumsy that was and how inefficient and whatnot. And at the time, I was actually writing a lot of assembly language code because it was kind of sort of part of the demo scene back then on the Amiga platform. Gotten very good at just writing like lots of tight inner loop to make lots of graphics happening on the system. And I noticed myself just really enjoying assembly language. Also, the 68K CPU in the Amiga was a fully 32-bit CPU with like 16 32-bit registers. It was a very luxurious CPU, if you will, with like a very high-level assembly that to me didn't seem like holding me back in terms of quickly being able to code things. And I was certainly, the computers at the time still had very little memory. So for me, having a plan of like doing a really professional language, for some reason, my idea was to do it in assembly. I probably could have done it in C, But at the time, this was what I was familiar with, and I started, and I just kept going. So Amiga E is a bit of, I mean, in terms of design, it's just like a bit of a hodgepodge of features. It tries to take the semantics of C, which I appreciated, give it a bit more of a Pascal-like syntax to be clearer and easier to read kind of thing. And it kind of also bolted on object-oriented and functional features, which I was getting into in my explorations of programming languages at the time. And yeah, it got very, very popular, surprisingly. At some point, it was like the third most popular language on the platform after C and BASIC, basically. Because the compiler, like a lot of people, could run this compiler, could compile large code bases in split seconds, generate efficient executables from that. It was just a very, very nice tool because it was all written, hand-coded in assembly kind of thing. And yeah, actually made a business out of it. I would sell that compiler to people, and I sold a ton of copies, and even, you know, was able to subsidize my my PhD from that. So it was good times. In fact, that's probably, you know, Lobster is picking up nowadays, but I would say Amiga E, under some metric, probably still my most popular programming language ever in terms of how many people actually have used it as their main programming language. So.
Yeah, and talking about you know, popularity of languages, Amiga E, as I understood, lasted decades at this point, and inspired other compilers and folks to build off the language. Do people still reach out to you about Amiga E? Do you see programs popping up every once in a while, or
Yeah.
What's sort of the state now? Yeah,
I'm still on groups where people talk about it, and there's a couple of people that have their own forks because I open sourced it when I was done with it. And, you know, surprisingly, because, you know, I sourced it, but it was a bunch of assembly code. But, you know, people have taken it upon themselves to take the assembly code and take it much further. And yeah, it still lives on. Probably not a huge language anymore at this point, but it's absolutely awesome to see that continue.
yeah, very cool. Every once in a while at SIGGRAPH, I see demo scene projects running on old Amiga and other old machines, and wouldn't be surprised if they were using your language and tools here.
Entirely possible.
So with Amiga E, you've got success. You know, you're doing your PhD. And then let's see, I'll try to get the order of these projects right. You do have the false programming language around 1993 or this time.
Yeah.
And the way I want to preface this is a lot of people have heard of the language. I'll say the first word, it starts with brain, and then there's a naughty word after it, which is sort of a Turing complete and simple language. But false was a pretty early project that maybe inspired this sort of style, or maybe was showing what you could do with a Turing complete minimal example. What sort of inspired you to write this programming language? Was it a challenge? Was it for fun? Or
it was for fun, for sure. That again came from my involvement in the demo scene, where it was, you know, everything is about small, simple, and just getting more and more clever with code, and I just kind of loved that. And I just realized that I had already been working on Amiga E, which was a big, complicated project. And no one has really done this for compilers yet. And I was just started to think, and it's like, well, what if you wanted to make like the smallest possible language? Like, what would you do? Immediately came to mind that like a stack language would obviously be very good. But I also like the idea of obfuscated things, much like the piece of code you showed earlier. So I did both, where I just used like kind of random symbols to represent pieces of code. I still made the language too practical, though, in the sense that like it was a fairly full-featured language. It had functions, if-thens, whiles, variables, you name it. So people wrote all sorts of things in this, including small games and whatnot. So yeah, just purely for fun. My goal was like I wrote the whole thing in assembly because, of course, it would output assembly, which was funny because you have a compiler that generates executables that are larger than itself when it operates, which, you know, is kind of like a mind F dirty word. Anyway, my target, for whatever reason, like sort of coding it, and kind of eyeballing, and it's like, okay, I can put this within 1024 bytes, which seemed like a great number. I posted that then on Aminet, which was the where everyone would upload their Amiga software at the time. Aminet was actually run by the guy that made BrainF ****. So he noticed that, and he was like, "Oh, I can do much smaller than that." And of course he did. He set himself a limit of 256, but it got even below that, I believe. But of course, his language is one that is incredibly hard to use, whereas mine is actually, you could actually program in it if you wanted to, kind of thing. So slightly different challenge. But yeah, his language being even crazier, got a lot more and a lot smaller, got a lot more fame as a consequence. So.
Yeah, I wonder, now that I know about this language, there's the classic, writing a full program or a ray tracer and putting it on the back of a business card. So maybe folks will consider the false programming language for this task here.
Yeah.
So that language starts, you develop it in around 1993. And then you decide to go from sort of this minimal, sort of beautiful language, how condensed can we make things? And then you sort of move to the BLA, or is it pronounced Bla programming language?
Just Bla. Yeah.
Bla. Okay.
Mm-hmm.
And my understanding is this is part of your master's thesis. And you're also starting to incorporate other things like higher order functions, different things borrowed from functional programming languages. And when I was looking at the actual code, it looks almost a bit like Haskell. So, and that you can express algorithms now very concisely with things like pattern matching and so on. So this is sort of just an interesting, what took you in sort of this direction, considering that false is sort of the minimalistic side, and then you're going minimalistic in sort of the algorithmic maybe side or expressiveness of the language. Yeah, how does Bla arrive in the history?
Yeah, so that's certainly no coincidence that you mentioned Haskell. Haskell has a couple of predecessor languages called Miranda and even one called Gopher that I was very much into at the time. I was generally just kind of expanding in terms of like what I was researching and what kind of languages I liked. I was super into functional programming languages, but even at the time, I wasn't a huge fan of trying to do like purely functional programming languages. I felt like, the kind of things I'm making, which are, compilers, games, those kind of things, I felt a more practical approach was something that is as functional as possible, but still an imperative language underneath, which is what Bla kind of is. The other aspect is that to some extent, Bla is a little bit of a mistake, because I made the classical mistake that programming language designers do, is like they look at a programming language design and they see certain things like, these things look similar. Let's all merge them into one concept, not kind of understanding that, sometimes things used for different things, having different tools and semantics is probably a good thing. In this case, I saw that the concept of an object, which is a piece of memory which names assigned to the parts. And then you have the thing called a stack frame or an environment, which are all the local variables where you call a function. And then this little object gets made on the stack, which all the, names for the little slots of memory on the stack. And I'm just looking at this exactly the same. Why don't we just merge these concepts? And it did have some interesting results, because now suddenly you were able to access the this parameter, not just of an object, but also of a function you just called. So you can have a function you just called and pass the this of that onto another function as an object and do all these crazy things. So it was pretty expressive and powerful. But in the end, I also learned from that is like, that's not necessarily good programming language design, trying to merge all concepts into one. It doesn't necessarily make the language that much more powerful. So an experiment, I will say.
Do you think that's from that lesson learned informing some of the programming language design that we've seen today, and that we've sort of got an explosion of different languages? There are more, as folks are saying, but you look at some languages like Go, which has sort of found its niche in writing concurrent and backend services or languages like JavaScript, of course, that, well, they're general purpose, but meant for the web and sort of maybe pushing features to make that easier. Do you sort of see that as maybe a future of we're going to have lots of more specialized languages, or like Lobster, for instance, which you're using for games right now? It could be general purpose, I'm sure, but maybe is specialized in a certain way. What do you sort of see in the future here?
Well, it's also not just the future, right? It's also our current situation. If anything, the amount of languages that we're using has definitely already exploded. I remember a time like some 20 years ago or whatever, when pretty much everyone was using either C++ or Java. And that was kind of the big languages kind of thing. And then since then, you've had the explosion of all these dynamic languages like JavaScript and Python and Ruby and whatnot. So today, there's more mainstream languages than we've ever had. So to some extent, that's positive. As someone who likes language diversity, that's a good thing. Will we see more of that? I'm not sure how many languages the programmers together can bear. Basically, I think it still has room to expand a little bit further. And I generally am also someone who, the idea of one language that can rule them all, that can really do all the things to all the people, that has never worked out, and I think that is still the case. If anything, the diversity of the kinds of programming that we're doing is still expanding, right? Not only in terms of hardware, of course, explosion in like GPU programming. Now we're going to get like AI processor programming. The scale, like some people use gigantic amount of servers to program. Others are in embedded or mobile devices, or, so what you need for programming is still diversifying and still getting crazier. So we're probably going to see more languages. That said, people are also getting good at making languages that can really span like a wider range of use cases. It's possible nowadays to make a language that is both fairly high level and it's got lots of high level tools, and is still also compiled down to an executable that's really, really fast, which is a language that potentially can span like more use cases. But in the end, I think if I see the current situation is that a lot of diversity of languages also just due to preference. Like in the end, it's programmers pushing what they want to use and what they like. And that's often more of an indicator, like why was this particular tool written in JavaScript? Well, not because it's the best language, I can tell you. That's what the guy or girl, hopefully, that started the project just had in their tool bag. So that will continue to happen, and I'm fine with it.
Yeah, likewise. I think we're in a really good spot in a programming boom, and we'll see what happens with more languages. And I guess they're all going to talk to C or assembly at some point, as you mentioned. So, with that theme in mind, we're now at about the year 2000 in your career here. And you're going from your master's into your Ph.D. program, I think, around this time. And you're working on another programming language, which I'll try to pronounce correctly, but Aardappel is the language.
Yeah.
And initially when I saw this, I thought it had something to do with Andrew Appel, a compiler developer.
Yeah.
But you told me this is another Dutch word and has nothing to do with the compiler writer, I guess. So
Yes.
yeah, tell me a little bit about this language, because I was very fascinated in one, how it's mirroring the trends around 2000 where the JVM is becoming popular, but also the graphical nature of this language. So what sort of inspired this? How do we land from Bla to Aardappel?
Yeah, so this is certainly, like you said, this was during my PhD. Of course, when you're doing a PhD, you got to do something, novel, because otherwise you're not going to get your PhD kind of thing. So this language definitely marks me being super experimental in all sorts of directions. And I'm actually trying to do multiple experimental things at once, as you already mentioned. So there's the graphical aspect, but another big aspect is the distributed nature of the programming language. So I'm trying to make a language that makes it super easy for you to run code across like multiple computers fully automatically, and the language just takes care of that. It also it combines this distributed nature with trying to do some novel also in terms of state, in terms of pure functional programming and not, by basically making the base language pure, but then the method of communication in a distributed fashion is how you deal with state. So, and it was my claim that that was a good marriage of like functional programming and distributed programming. And yeah, just for good measure, I threw on there a completely graphical environment. For the longest time, I've been into the idea of graphical programming languages. That's finally has subsided by now, and I'm happy with my textual languages nowadays. But you know, as many people, the idea that a graphical language could potentially be more powerful than a textual one was still in me. Most graphical languages at the time were data flow languages. So, you know, lines and boxes with data flowing between them. This was different because it was a rewriting language, a tree rewriting language. So the idea is that you have a structure on the left and a structure on the right, and the language is going to map from one to the other, and that's going to express computation. So yeah, if for all those listening in and their eyes glazing over, it's okay. This is really, there's so much craziness about this language. And then the implementation. This was also at the height of the initial ramp up of the JVM, and I've always compiled my languages down to machine code. And in this time, I was like, okay, let's try the JVM as a backend. A big advantage was there that JVM had like remote procedure calls and all sorts of stuff built in, so I could actually use it as like a distributed runtime as well. Whereas if I had gone native, I'm not sure what I would have done, but it would have been a whole lot more complicated. And then the IDE could be, because it's graphical, could be coded in Java as well. So it was an all-in-one package. Was kind of nice. I already ran into like issues with Java there, performance, and a lot of issues were not very good. But it certainly was fun to build at the time.
Yeah, very interesting. So getting into the graphic stuff, I mean, was some of the tree rewriting, were there interesting insights from that and on maybe optimizations or just, I don't know, a different way that you could see your program? I know it's kind of fallen out of favor, as you said now, but did any interesting insights come out of it that we take for granted now? Or
so the rewriting is actually somewhat similar to functional programming when you use pattern matching, right? So when you write your append or something like that in a language like Haskell, you can say it's append. I have a head and a tail of this list. I'm going to rewrite that as an append with the tail being appended, blah blah blah. And so rewriting language is just a more hardcore version of that, where you basically make no distinction between the data structures and the functions. So you can really use them as temporary data structures or anything you want. So it's slightly more powerful. It seems to work well for visual programming. One thing I did on top of that is programming by example. So I didn't want to use like placeholder where you say X or Y, like it is, or the head or the tail of a list or something, but instead example. So you look at the code, it's like, oh, look, it has this example list, it's splitting it in two, and this is where the parts go when you're rewriting it. And I can't make any claims, I feel, about like whether all of that was so much better than any program we do nowadays, simply because that language didn't get as much use as I would have wanted. It's kind of hard to make those claims anyway.
Sure. So at this time, and I'm condensing the timeline very, very quickly because as many folks know or finding out, PhDs do take a long time. But you develop this language, and then the next sort of project that I see is you're getting, you're doing lots of programming language work and compiler development, and then you start development on the Cube engine from 2001 to 2005. So was that something that you were that you sort of jumped into on your own? Was this a side project? What sort of happens after you graduate your PhD and get into the Cube engine?
So I've been to games for a longer time, but it really kind of got to a boiling point with like the release of games like Doom and Quake, which I was playing intensely during my PhD. Let's not tell my supervisor. And of course, the online play. And a part of that was the level design, which I got into for both of those games. And I just like the whole building worlds in 3D and then being able to play it. Like, I just really got my mind going. And then, of course, as a programmer, comes the moment is like, I want to do this stuff myself. But realized at a time, like a project like Quake, with brilliant people like Carmack, it's like, I don't necessarily have the time or the ability to kind of copy what he does. So I'm just going to take this and simplify it to like his logical conclusion kind of thing. Also at the time, I will say, I've gone through waves in terms of like how extremist I've been in terms of wanting code to be small, fast, and simple. And this was one of those more extreme points where I was like, I am going to, like the first version that I released of the Cube engine that had like functioning gameplay and everything was like a 64K executable, for example. And that was a fully OpenGL game in 3D, everything, all the bits and bobs, which give you an impression of like how extreme I was about things. But it also reflected in its design. So Cube is effectively, it's like a slightly more complicated height map. It's like you have two height maps from the top and the bottom. You kind of fuse them together. You have some flags that say like where the walls are, basically that connects the top and bottom height map together. This kind of the structure of Cube, basically. So I made it crazy simple. Because of the crazy simple structure, the physics were super simple. I did lighting and shadow casting, which were incredibly simple, just a bunch of like line tracing routines. And that's the thing with simple code, is like once you make certain data structures simple, all the code that follows from that also, it has a kind of a cascading effect. And that was certainly like proven out by Cube. The code base has been absolutely tiny, some 10 times bigger than the Quake code base, which at the time I already had access to, or something like that. So that's kind of how it started. But then I knew a lot of people in the Quake and Doom level design communities, and I kind of got a lot of them on board making levels for the engine. It got popular in multiplayer, and it kind of exploded from there. Got more people collaborating. I got a good friend of mine, Lee Seldsman. He came helping out with the engine. Yeah, it just became it was an open source project from the get-go, never commercial, but it just kind of exploded in popularity from there.
Yeah, there's some really beautiful images, as I mentioned. I mean, I remember from there used to be a website, devmaster.net, which listed all the graphics and game engines, and I would just peruse those. And so that's how I first stumbled around Cube. So I'll put some images up of it. But it's interesting how from this simplicity, there were other interesting sort of behaviors that came up. Like, for instance, the multiplayer, like you said, which was a feature. But my understanding is you could also edit the levels in real time, which I was just at a game developer conference talk here in 2024, and that's something folks are working on still. But this was 20 plus years prior. Folks are doing this. So where does that feature come from? Are folks modifying this? Are you adding on to it? What kind of sparks some of these features?
So first of all, I've done a lot of like the Quake Doom level editing. Quake in particular, while it was super interesting, was problematic in the sense that you were editing a level in some kind of 2D CAD view, and then you had to go through, what was it called, QBSP Viz and the lighting compiler, which could, on those old computers, could take hours kind of thing. And then you saw your game in 3D, hooray! And I was like, we can't do it this way. So I was convinced that from the start, I wanted to be able to just kind of modify the game in the 3D view with like no delay of any kind. But because you were able to do this in first person in the game, and then I added multiplayer, and now we're flying around in multiplayer, and it's like, well, if I start modifying the level, the other people won't see it. But what if I just send every modification as a network message along with the rest of the multiplayer? And I did that, and surprisingly, it didn't take very long. I must admit, it was limited in the sense that, like, if you had to kind of make sure you were synchronized, like people are connecting. If you do something like someone's connecting, you quickly make a modification, or there were situations or people trying to modify the same block at the same time, where basically you would get out of sync. But I didn't care because I basically said, like, well, someone's got to save the level, and that will be the master copy, and figure it out. But it was really simple and really effective, and people loved this. And of course, one of the fun thing was, I remember being on a server, and we were like with like 6-ish people, all kind of modifying the world at once, and people were having a blast. It's like the first thing I've ever seen anything like this, being in 3D and being able to do that. And one of the people said, because at the time you had to go in what was called cooperative edit mode to be able to do this, because I didn't want to allow this like in the middle of a deathmatch match, because of course you can't just tear walls down. And someone said, it's like, you just totally need to make this into a gameplay mode. It would be the best thing ever. And I'm like, nah, this is meant to be for editing. Editing, gameplay, two separate things. And of course, some 8 years later or something, someone comes around and makes, building and editing in 3D while you're playing, makes out a big thing, and ends up selling his company for $3 billion. But I'm not angry at that at all. I'm totally fine. I'm just like, anyway, just kidding. But yeah, that was kind of funny. So.
Yeah, so what we're saying here is the creators of Minecraft maybe owe you some royalty dollars here.
Yeah.
Or I'll make that claim on your behalf.
Minecraft is so different, and I truly appreciate Minecraft for what it is, and it did so many things endlessly better than I ever did, so I would not want to claim something like that. But yeah, I feel like if I hadn't been so stubborn, I could have been close to going to that direction. But I was stubborn, so here we are.
Now that said, we're going to get into some of your exciting game studio stuff that you're doing now, but but even with Cube Engine, there were great games. Like I was reaching back and looking at Cube Assault, which folks are still making videos and posting YouTube. So how does that make you feel, both as one, you've got your sort of you've been doing some teaching, you've been a long time developer, but to see your tools and folks using them to make great games and fun games, I don't know, how does that make you feel when you kind of look back on that?
That is certainly awesome. I will credit that to my choice to make it like open source right from the get-go. That is always kind of got lots of people involved, give lots of people lots of confidence that their contributions are not going to be for nothing. That kind of thing. And yeah, it's still going strong. There's still a large community of people playing this game and making content for it. It just keeps on going. It's crazy. Yeah, I love it. What more can I say?
Yeah, so very cool. And you loved it enough that there was a Cube 2 engine as well. And this time again, this is released around 2004. And this is also when I was looking when OpenGL 2.0 is being released, so graphics capabilities are increasing. Was this something that you were looking into at the time, the more programmable pipelines, and did that sort of inspire the second engine, or why the next rewrite? What things were you trying?
No, the second engine wasn't really about graphical features. It was more about the world structure. Certainly, like how do you represent the world in 3D, and what is it that you can edit, and how does it feel to the player, has always been one of my guiding principles in terms of making engines. And the big difference from going from Cube to Cube 2 is essentially going from 2D to 3D. Like the first Cube, like I said, it was a bunch of height fields. So editing could mostly only happen in 2D, even though it's like the result looked like 3D. It was kind of like Doom in that sense. And Cube 2 is fully 3D in the sense that like all three directions are treated equally, because it's all stored in an octree, and every leaf of an octree is like, we call it deformable cubes. So basically you can push the surfaces of an octree leaf in along its edges, allowing you to basically create like almost any shape out of a cube. And it was more that idea of world representation that made the new engine, because then we needed to change all the rendering, the physics needed to be changed, everything needed to be pulled out and changed. So
very cool. So it's quite a jump in technology. At that point with the data structures and so on. Now while you're working on Cube 2 and in between this time, you're also doing work at Crytek. Is that also
Mhm.
correct?
Yeah.
When was that time period, and what type of development were you doing?
Yeah, I started Crytek in beginning of 2001, I believe. Funnily enough, I got that job because the CEO of Crytek was also active on the site called Flipcode, and I had just posted my Cube engine on there, and he was like, "Oh wow, this is amazing. We need this." In particular, he had the idea that like something like my Cube engine could be used for like the interiors, because they already had a really great landscape engine that they were working on for what ended up becoming Far Cry, but they hadn't figured out like how to build their interiors yet, basically. And I basically had what's essentially an interior engine. That didn't end up working out. I think probably Cube engine a little bit too simple for their requirements in the end. But that was how it got started. Ended up working there, and yeah, that was a lot of fun. I got to know so many awesome people at Crytek. It was one of my more more important points in my career in terms of getting to know people and where to go with that. So
Yeah, Crytek I've always looked at, and especially during that time period when Far Cry was coming out, really a crown jewel in gaming, and really impressive feat. And again, today is still an excellent engine with lots of great technical contributions going into it. So I think that's very cool that you get to say you worked on some portions of that. So I mean, at this time, then you're working on or had been working on Crytek. You've got sort of some open source projects. And I love the reference to Flipcode. It's still archived somewhere, so maybe folks could find your articles and engine stuff there. But that was a really fun thing. And then you've got all this engineering experience. When does SMU Guildhall enter the picture? Is this after your time at Crytek, or?
Yeah, that was basically the time I was thinking of moving on from Crytek. I was working there with some good friends of mine that were originally from Texas, and they knew that someone was starting like a game development program, a master's program for game development in Texas. And I just threw out the thought like, hey, you know what? I bet I'd be a good teacher. And before I know it, I'm going to plane to Texas, talking to the dean there, and and ended up joining there. Turns out that teaching is not quite as easy as I thought it was. One of the things I found out very quickly is like I delivered my fantastic lecture, and I'm just expecting everyone to just have like an amazing understanding of what I just said, and a whole bunch of people are just kind of deer in the headlights stare, not understanding what's going on. And I learned to basically do much more teaching on a per person basis. But yeah, was very interesting doing that for a couple of years.
And did you have a particular course you enjoyed teaching the most, or one that you're particularly proud of?
Well, that's got to be my compiler course, of course, because it was a game development school. So most of the classes I would teach would be like graphics and character animation, a whole bunch of those kind of topics. But I was like, they're all basically all the students were building their own engine as a way of learning. And, these engines need scripting engines, and they're not going to, so it was my idea to increase their software engineering ability by making them make their own scripting engine. And of course, I had a lot of passion for that with my background in programming languages. So, yeah, that's probably what I enjoyed most, to be honest.
Yeah, and I'm going to point folks to, because again, this has been such an incredible thread through your career, some of your rendering engine architecture talks on scripting and WASM. When does that come into play? Because you start working on WebAssembly at some point in your career as well.
Oh, yeah. So that's kind of much later. I joined Google at some point. I spent first a couple of years working on in a game development team where we're trying to write libraries and technologies to just make game development better on Android and also on other platforms. And that's where flat buffers came from, for example. But then at some point, I moved on from that team to the WebAssembly team. And that was because a good friend of mine was there, and I talked a lot with him, and I was just like, wow. From my compiler background, we now have the opportunity to, for once, define like a really, really good VM infrastructure that all programming languages can use, and it's going to be so good for programming languages. I have to be a part of this, particularly because, of course, there was the JVM, but the JVM is biased towards Java and garbage collection. And as you may know by now, I'm not a fan of garbage collection. So, and WASM was spec'd from the start to be able to handle languages like C and C++ and Rust. So I was like, that's great. There's finally a VM that can handle any programming language. There's basically going to be no limitations. So I very much wanted to be part of that. And yes, it's been several years there hacking on LLVM and lots of other WASM tools, and good times.
Excellent. And I think that brings us about to what you're doing now, which is at VoxRay Games, which is your studio. Can you tell me just a little bit about the projects and what you're trying to achieve with VoxRay? I know you're making a game, obviously, but what can you sort of tell folks about who haven't been introduced to VoxRay?
Yeah, so the interesting thing is that in some kind of ways, this project is a follow-up to the cube engines that I've made, in the sense that it has a lot of similar structure. It again uses an octree for everything. It even currently uses the physics code from Cube 2. So there's a lot of overlap there. But rather than doing everything with polygons, this time we're doing everything with tiny, tiny, tiny voxels and ray tracing. That's a little bit on the tech side. I guess the other big thing is that, of course, it's built on Lobster. I say built on Lobster because Lobster is not just a scripting language. It really is the programming language for pretty much the entire engine and game. Only the core, hardcore, graphics rendering and physics routines are in C++ as a library, but the entire structure of the game is in Lobster. So that combines that. That's on the tech side. On the game side, what kind of game is it? It kind of combines like several genres of games that I enjoy playing together. So it has a core of what looks like a first-person shooter, but then it kind of branches out into RPG and survival territory. Trying to make a game that is very, very creative, much like, finally, unlike Cube, I'm allowing all that building and destroying to also happen in game. I've learned from the Minecraft experience. So it combines like a whole bunch of things, which I'm excited about. But the most important thing about that is I want to go really, really far in giving the tools to shape that gameplay to the gamers themselves. So the idea is that it's going to make it very, very easy for you to build your own world. Of course, and you can just build all the wonderful voxel art that we have. But then your ability to say is like, I want this world to be more like a shooter, more like an RPG because I want to tell a story, or more like a survival game, or maybe even something else that we haven't even thought of yet. And being able to do that just entirely from within the editor of the game, to create a community where at some point, like I'm going to find a new world to play. It's like, oh my God, someone's made this crazy thing, and it's this crazy RPG experience or something, and it's something wonderful that I hadn't thought of. It's like I don't want to be the person that has to think of all the possible gameplay that happens in my game. I want my users to be able to take it as far as possible. This is kind of the direction we're going with this.
Yeah, well, it's a really exciting project. I mean, both from the technical feats, like you said. I mean, it's a very beautiful game. It's ray traced. It's going to look great on all sorts of hardware, I think, for folks who are going to be playing. And I think it's also going to be very fun, like you said, because, like you said, you're empowering the players to create and have that sort of emergent gameplay that sometimes, you can't always plan. And I think that's another trend, maybe for a different discussion about what's going on in the game industry, but that's very exciting. And again, I can't wait to see and to play more.
Yeah, I must certainly get you a tester key. So.
Yeah, absolutely. But, I think the thing that's exciting and folks have been waiting for is to actually see, since this is built on Lobster, maybe we should take a look and maybe do another screen share of the Lobster language. How about we do that?
Sure, go ahead.
Let's do it. All right, so I'm going to go ahead and share screen. And, by intention, I haven't looked super carefully at Lobster Language because I want to give you sort of the first impression as somebody
Okay.
else would looking at the language. So I've got your website here, and the first thing I'm going to ask about is how did you get Sterlen as your URL? That's a good one.
I got that .com like a really long time ago, somewhere in the 90s already or something. So this is at the time when these kind of names were not taken yet. I'm pretty sure, like, even though this is the name of a C function, I think nowadays you would not be able to get that anymore. So that's kind of how I was able to get it. My idea was like, I don't want like a serious name like Wouter van Oortmerssen.com or something. I want something a little bit funny, something that programmers can appreciate, like kind of like an in-joke of like, you see that URL, and if you're someone that knows C, you know, you're going to appreciate it. And that's kind of the audience I wanted to appeal to anyway. So.
Absolutely. Very smart and clever and fun, as you said. I love it. So let me make this a little bit bigger here. So what you've got here is a programming language that combines the static typing. You've got compile time memory management. So very lightweight, but you want control for things like games, as I imagine, of your memory. Friendly and terse syntax. And it's going to do most of the heavy lifting for you. Okay, so if I can ask, I mean, were there particular programming languages that inspired you to develop Lobster? Where were you sort of looking? What were you coding in that said, you know, this is a good sort of base of what I like in a language?
So one thing to know about Lobster is, like, unlike some other languages, it has really evolved over the years. It's been kind of my playground. Like, I've developed other languages where I had like a core idea and I just kind of made the design all in one go, and that was it. Lobster is a language that is just like, it started out being a dynamically typed language, for example. If you so it got strong typing, and it got all that memory management stuff that all happened afterwards. So in terms of when I started, my biggest focus was on making a language that was easier to refactor. And again, there comes that theme again. It's like, I want to be able to move code around with the least amount of fuss to keep my code in shape. And I felt that other languages were not doing so great at that. So I started out with a dynamically typed language because, of course, there it's easier. But even when I added a type system, I went very deep on type inference, simply to allow me to write most code without types, and then being able to still move code around very quickly, and then the types just kind of matching up as far as possible. It's shifted its focus over the years. Like, initially it was all about refactoring, and nowadays, you know, the typing and the memory management is kind of at the forefront, to where it's become a language, you know, a little bit more in the Rust direction, in the sense that the memory management is able to do like compile time memory management in a way not dissimilar to Rust. And together with the type checking, this has now actually become a fairly efficient programming language. That it's currently not crazy fast because my implementation is just not that good. This language does have the potential to be a very, very, very fast language, given enough effort. So, and that's also what I'm needing now, because I have a very large code base. That's the entire game and game engine written in this. And so far, we've managed not to run into any speed issues with the language. But I want to certainly further develop it in a direction where it can basically take on more and more heavy tasks, because it's fast enough for that.
Yeah, so I'm hearing a few key things, and I mean, these are things that come from experience, I think, from your, you know, programming career. And the first one was the plasticity that's somewhat called of the language. I mean, the ability to evolve and change your code. And it says, I mean, we'll get down to the features. I mean, coming from games can be something that change based off the design frequently. So it's kind of interesting that we're seeing a programming language here focused on that effort of things change, which is just reality being a software developer. So I'm very enthused to see that that's being captured here, because that is one of the hard parts of programming, I think.
Yeah, I feel that programming can best be seen entirely as not like one program that you're looking at and its structure, but at the progression of like the modification, almost like we use Git and commits nowadays, right? the programming activity is more like a list of commits than it is like trying to architect a code base. Like, how do you make each change possible that it's very easy and quick, but at the same time that you don't introduce any future issues with these changes, because then all your future changes are going to go slower and slower and slower. And that's kind of what I have in the back of my mind when I develop a language like this.
Yeah, that's a very interesting perspective that comes from experience and development here. Now, if we just touch on this feature before I scroll a little bit, compile time memory management, and you said it's more akin to Rust. Is this talking about safety and trying to verify things like ownership or uniqueness, or talk about pointers? This is where we're going in the Lobster language?
Yeah, so it's a little bit different. So Rust comes at this from a very principled point of view to basically require the programmer to annotate everything that deals with ownership. I'm coming from the opposite direction. By default, this was always a reference counted language, and I'm using compile time analysis to remove most of that reference counting. So it is completely automatic to the programmer. But I do go much further with this because there have been languages in the past, even Java and Go implementations have often removed, were able to remove reference counting or garbage collection operations, move things to the stack, those kind of things. I'm going a little bit further with this than those kind of past efforts, which I'm able to do because of the structure of how the implementation deals with like type checking and things like that. Everything goes in call graph order. So I'm able to do analysis that other languages can't do, where I have a complete picture of like how references flow across even function calls and things like that. And I've tested with this and noticed that I was able to remove really large amounts of reference counts from the compiled code.
Yeah, impressive. That makes sense. Like you said, we're able to get some of the speed, for game programming, for instance. And if you could do all this at compile time, that's a very strong feature.
Mm-hmm.
So I'm going to scroll down here to just some of the features here of the language here. Again, you're sort of emphasizing refactoring here. And let's see. So we've got static typing for safety here. Now, is there inference in the language? So if I'm doing something like auto, because I sort of want to do a dynamic type and it infers the type, or how is that done? And we'll look at a snippet of code in a bit. But is the typing also inferred, or is it explicit? Okay.
Yeah, it can be either. You can definitely annotate types as much as you want. The type inference goes much beyond what you have in auto or things like in C++. It's much more akin to what Haskell has, but it goes even further than that. In the sense that this automatic type can go across many function calls in complex structure. You could pass functions to functions and have them do all sorts of crazy stuff, and all without any kind of annotation on the types of the parameters, and it will figure it all out, basically. And that is to some extent because it uses monomorphization to compile this. It's similar to C++ templates. But unlike C++ templates, it will do it all automatically for you behind the scenes. And that's because in Haskell, for example, there are limits to how far you can take type inference, because each function needs to have like a generic type. Whereas here, I only type check a particular instantiation of the generic function. So it's much easier to specialize each function towards what the caller needs and what kind of types it's passing in, what kind of lifetime of memory it's passing in, and all those things.
Okay, fascinating. Can't wait to try it out here. I mean, that sounds very, very powerful here.
Mm-hmm.
Now, we've talked about a little bit of the lifetimes here. We've got anonymous functions and lambdas. I'm assuming, could these be local functions, I guess just placed anywhere then, and passed around?
Yeah.
Perfect.
Yeah, they are specifically meant for passing to other functions, for creating higher order function calls and things like that.
Perfect. I love this bullet point here, vector operations. I think every modern programming language these days needs this. Well, again, I'm coming from a graphics and game programming background as well, so it's beautiful to see in. Let's see, unified overloading and dynamic dispatch, in and out outside classes. Okay, supporting specialization. Let's see. Okay, so dynamic dispatch. So we have things like virtual functions and being able to override calls here. What exactly is, let's see, unified overloading? What do we mean by that here?
What I mean by that is in most programming languages, you're specifically making a choice that if you have multiple method implementations for multiple types, then you're saying in some language like this is virtual, you're basically preparing for the dynamic dispatch. In my case, you just declare all these functions, and then depending on how it gets called, it will either be dynamic or static. So in C++, for example, if you make something virtual, but you then call it with a type that is always one particular type, you're still going to get a virtual call, even though it's not necessary. In this case, it will choose that at compile time for you. And also in terms of syntax, it looks the same. Overloading and dynamic dispatch, they look the same. The only difference is that the dynamic dispatch is when you have subtypes where you cannot guarantee that the actual value is not one of the subtypes. And once the compiler has that, it will do dynamic dispatch for you. But there's many situations where it actually can do static dispatch, depending on context. I believe this is not dissimilar to, I gotta be careful now because probably someone say something dumb. But in Rust also you have the ability, I believe, with traits to basically choose like, okay, this value I want to be able to dynamically dispatch on these things, whereas other values that are actually the same type, I want to just treat them statically, which I think is a wonderful thing. It should depend on the context whether a value needs dynamic or static dispatching.
Got it. Yeah, that's very cool. I mean, and again, coming from game programming, we're trying to be careful of things like dynamic dispatch and what would be virtual functions in C++. And I guess as C++ programmers, or in my background, we try to use like templates or specialization to get rid of these things at compile time. So if this is inferred or there's an easy way to do it, that's wonderful. Let's see what else we've got here. Immutable inline structs here. Okay, so immutable, non-changeable. Inline means I can just sort of declare these. Am I treating these sort of like tuples or something so that I can just have a struct if I want to say pass multiple values or return multiple values? The
inline part is mostly means that they're stored inline in their parent, so they're on the stack or inline in the parent object or wherever. So it's very similar to how structs can be treated in C++ or Rust, but also C# has this feature as well. And a lot of people, especially in game programmers, are very happy that C# has this feature, whereas, for example, Java does not, and it makes a huge difference, like to how you're implementing your 3D vectors or something like that. You can't just have every 3D vector being like a new memory allocation. So, so these inline structs, the way they're treated in Lobster is you have a struct with an X and a Y in it that is exactly the same cost as if you had two variables that are X and Y. So it's like zero overhead, basically.
Beautiful. That's beautiful. Let's see here. GIL. So GIL, I guess coming from Python, the global interpreter lock, we're getting rid of that. So no overhead there. And let's see, raceless distributed memory model for multi-threading. Okay, so you're gonna have to tell me a little bit maybe more about the memory model, but what types of things are we doing here, the language, to make it safer, avoid data race conditions? I mean, part of this is maybe the immutability in the language. Are things immutable by default? And is there sort of a strong order, I guess, for how operations are ordered? What can we say about the multi-threading here? So
this is actually a fairly high-level feature. Funnily enough, it has some relationship with that language Aardappel, which we talked about before, in terms of how it does a distributed memory model. So it's specifically, it's distributed, not shared memory, which means that when you want to send a message to another thread, you basically put this in a big pool, and the other thread then picks it up from that pool. It comes from, if you want to look it up, there's a set of languages called coordination languages, of which this language Linda was a famous language way back when. Or people call it tuple spaces. I believe at some point there was an implementation for Java that did tuple spaces. But it's a very different kind of model for doing concurrency. So there's no sharing. The cool thing is that you can just basically boot up however many threads your hardware supports, and each of them will be able to run completely independently. So they all have their own memory allocator. Any memory allocation in Lobster does not do any locking, unlocking, or any kind of checking of any kind, because the memory pool is completely part of like one VM per thread, basically. So the sequential code can run at maximum speed. There is some overhead then for any kind of concurrent communication, but I feel that's the right default, where basically that is where you pay the cost. And yeah, the other cool thing about it is that you automatically got end-to-end communications. So for example, if you set up some kind of message passing structure where one says like, okay, here you need to go do this task, and some other thread picks up that task, because it goes into tuple space, I can now say it's like, oh, this is actually not going fast enough. Rather than one thread doing that task, I'm now going to boot up two threads. And that makes no changes to your code, because they basically will pick up tasks from there as they go. So it's a fairly high level, but I really, really, really like this kind of... I would not want to deal with like explicit sharing, locking, unlocking inside the sequential code. I feel is like a dead end to me in terms of this kind of programming.
Yeah, I guess this is where, I mean, we've seen cement languages. Immediately what came to mind was thinking about things like Erlang and an actor model, with things sort of having their own space. But as you said, if you're getting things like almost effectively, I guess in the C++, in my C++ mind, I'm thinking about thread pools and managing all of these and coordinating those. We're sort of getting that for free, I guess, by having everything more thread local and being allocated in their own thread. So yeah, that sounds wonderful. I'm all for doing less work for more performance.
I must admit, for anyone reading along, the whole distributed, the multi-threading side of this language, it's there. It's not been developed a ton. In fact, we don't even use it at the moment. So don't go running to Lobster as being the, you know, some kind of next-gen distributed programming language or whatever, because probably some more work needs to be done before that's the case.
Yeah, but we are saying, or I'm saying for you, because I'll advertise, do try out Lobster and see if it fits your needs here, because this is pretty neat here.
Yeah.
Now this next, let's see, so you've got Python style indentation. And again, the reason we went through your whole history is because I want to inform where you're at. Does this come from things like Sloppy, where we first started the conversation and you said, I want neat code and we're going to enforce style in this language?
No, I would say it came from that. Most language I've done in the past have been more C style. And I guess for me, the refactoring is easier with an indentation-based style, because usually you're copying like whole lines, moving whole lines on. Your code is a little bit denser because there's not like space being taken up by braces and all sorts of things. So I really just enjoyed, I'm not a big fan of Python, the language, because it's just way too slow. But the syntax certainly, I think, is the best syntax around. And I was like, okay, I'm just going to go there. I was never trying to make the most popular language ever, because if I did that, I probably would have been better off choosing C style. But, you know, this seems to fit the language much better. So.
Yeah, brilliant, brilliant. Well, we'll get into trying here. I just want to go through a few of these other, highlight a few other interesting things here. In particular, what caught my mind with Lobster is this bullet point here, because again, this seems like a crown jewel of development, meaning being able to directly just run your code and have a JIT compiled, or do the compilation for your final build, or when you're doing more of a test where you can, you know, let a large code base develop here. So is this is this JIT compiling to some bytecode? Is this JIT compiling to JVM, again, from your previous languages? Where does this feature come about, and how is this working?
That's actually kind of funny. I use libtcc, so it actually uses C. The output of my backend is therefore something that can either look like C or C++, depending on where it's going to. and libtcc is incredibly fast. So, for example, when running, it spends less time in libtcc than it spends in my compiler. So my compiler less efficient than libtcc, which I'm a little bit ashamed of, but can't have it all. So that makes the running pretty much instant, and of course convenient because if you're generating C, then it can easily go to a better compiler as well, because libtcc is definitely, in my measurements, some 3 to 10 times slower than an optimizing run of Clang. And yeah, very convenient. While we're developing the game, we are running with the JIT pretty much all the time. And that's also good because we run on fairly fast hardware. So if something starts running slow CPU-wise, I know it's time to optimize. And then I know that my shipping build, which will go through an optimizing compiler, will run great on even like the slowest laptop CPUs. So no worries there. But in the end, it's like it's almost laziness. In the past, I've often done my own machine code generation and whatnot. And this time I was like, no, there are just amazing C compilers out there. And yeah, you could also generate LLVM IR, which I'm actually very familiar with because of my past jobs. But this is just the simplest. I would recommend everyone making their own programming language. Just generate C, get it over with. It's and maybe at some point we'll do something even better. But for the moment, this works just fine.
Yeah, absolutely. I can echo that too. I've written a few compilers that just spit out C code, and then it's portable almost everywhere. So why not? And you get the speed and optimizations. Let's see. So we've talked a little about the reference counting. You've got a full graphical debugger here. Again, very important for the tool ecosystem. Dynamic code loading. So I guess, should I just call this like some sort of hot reload system that's built in? You can just load in Lobster files, or
you can load in Lobster files. Yes. Important to note, the disclaimer is like that will not run into the same program. So you'll actually get like a separate VM that runs the dynamically loaded code, because Lobster is a very statically compiled language. So you can't just do class loading or whatever some other languages do. That would not work. It's not that dynamic.
Got it. Okay. And let's see, we've talked a little bit about the speed, but that's going to come with time. Again, let's see, how old is C? 50 years at this point. So when Lobster turns 50, I'm sure it'll be much, you'll have your time to catch up. Let's see. Okay. And you've got different ways to deploy, which is kind of neat here. So you can just go directly to a exe here, or a compressed bytecode file. So tell me a little bit about what I'm understanding here. Is this packaging everything up here, or is this, and this reminds me of sort of an IR thing, but let me let you explain maybe.
Yeah, so because the language was at some point was a dynamically typed language, at the time was also that we had an interpreter. These days, the interpreter, so that's actually kind of incorrect what that says. There's no more interpreter mode. There's only the JIT mode, which is kind of like an interpreter, I suppose, and the ahead of time compilation mode. But it still has the bytecode internally as a representation. So you can save that off. And we have this thing called a pack file, which not only can contain the bytecode file, but can contain like shaders and textures and other files your game needs. You'll get one pack file. And if you ship it together with the main Lobster executable, you don't even need to recompile, you basically have a working game. So I think that's very useful. Yeah, I think that's what you were asking.
Yep. Perfect. Yeah, I understand that. I mean, that kind of goes through a lot of the engine stuff here. I'm going to kind of skip over here, but it makes sense if you're building a game that you're packaging a lot of the high-level components, have connections to different libraries, input systems. Again, I could imagine folks who are doing game programming, Lobster might be a very viable choice for folks who are watching this to try. So let's see here. So let me just I'm going to scroll through this quick, and then I actually want to look at a little bit of code with you. And actually, I want to see if we can get Lobster up and running here. Just again as a live example here. Always dangerous to do, but we're gonna try.
I'll just look the other way when you're doing that.
Yeah, but let's see. So if folks just Google Lobster Programming Language, I think we can get to the repo here, and let's see what you've got here. And don't worry, I've done this 30 plus times now, so I always figure it out. You've got a nice GitHub language page here about the language. And I'm pretty much just gonna, we know about the language because we've got the creator here. But let's just go to the getting started guide here. And I am gonna cheat a little bit just for time's sake and grab one of these pre-built binaries here. And while I was looking at this here, let's see. You were working on this before this conversation, so that's awesome. Or at least your CI system was. So let's see if we could give this a try here. And if folks want, I guess there are just some binaries here. Let's see if I just download. Let's do the Linux build here. Maybe what's down here? Oh, actually, let me scroll down here. The
There
artifacts. This is what we want. Yep. So let's give this a download here. And let me open this up here. And whoop. I'm just going to extract this. Here we are. All right. And that just gives me basically a executable here. So let's just open it up. And let's see what we got here. Okay, so I got my executable. Maybe I need to make it or give permissions here.
And crash.
And running. No crash here. So this is good news here. Let's make this a little bit bigger here for everybody watching. Let's see here. A little bit bigger. How do I do this here? Profile. There we go. Big font. Let's try that. I guess that's okay. Okay, so I should be able to, in theory, just run this and pass in some Lobster code. Is that true? I've just got the compiler here. Or
No.
do I need more in my toolchain?
I'm afraid that's generally not the case.
Okay.
It does want its files, like things like the modules, like think of standard header files, if you will, that are not included in the executable. So in effect, there's at least one module it always wants to include. So this is not going to work. You'll still need the actual repo distribution archive.
Okay. So let's clone the repo and read the directions, the rest of the directions then. Let's see. Okay, so let's see. I'm going to download Lobster here. Okay, let's clone this repository. And let's see here. And let's see. Let's download the zip here.
You can get the repo if you want.
Or take the repo, okay.
It just might take slightly longer.
Let's see here. Lobster. Oh, I see. Repo. Let's do something like this here. And let's see. Then I need to place the binary that I've just obtained in the bin folder. Okay, so we can do that. Let's go into
so basically,
Lobster.
that just recreates the repo in the state that if you would have compiled it yourself, then that's where it would have ended up.
Got it. Okay. So we haven't really saved much time then by doing this. Let's see here.
Well, I guess the C++ build of the compiler doesn't take super long, but
yeah. Let's see here. Where am I? Let's move Lobster into where we are. Okay, we've got it in our bin directory here. Okay. And let's see here. Okay, so we've got Lobster. Now, since we have the whole repo, that's giving us the modules, which you mentioned are the standard library. That's correct?
Yeah, and samples, tests, docs, the whole shebang.
Perfect. Okay, so maybe now let's see. I'm giving you a little user preview of what maybe a user would do. We've got the build, any other instructions here, running it. We've got the Lobster executable in the bin folder, and we can run this. Okay, perfect. So why don't we try what's in the documentation here? So
it's
again,
graphical. Let's see if your OpenGL works.
Let's see here. Let me type this out. Bin Lobster. And we're going to look at samples and height tree lobster. All right, are we ready?
Yep.
Let's see what
Ouch.
happens.
It's going to crash.
On my other window.
No, there it is.
Beautiful, beautiful. Pythagoras, tree, and lobster. All right. And this is the first official, again, as I said, no cheating here, so it works, which is always my first test of a programming language. And now I'm ready to try more. So beautiful. So why don't we go into one of the samples here? We'll go into one of the samples and then we'll start wrapping up because you've been very generous with your time. But we've got to look at the language here. And you've given us a lot of samples here. Let's see. What would be a good one? Well, most of these look like they're graphical ones, which I love here. Why don't we just start off with a good old cube? Because I think we could probably parse some of that here.
Oh, that's actually one I didn't write, and it's kind of long-winded. So
okay,
maybe you want to start me with that same one, that pith tree. It's just like it's really, really short and.
Yeah, let's do that here. Let's see. CD into pith tree. Oops. Let's just use Vim here. Pith tree.
Oh, samples pith tree.
Oh yes, yep. There we go. All right. Okay, so as far as the language goes, let's see. We've got some imports here. Vec for the mathematical library, colors, and GL. Okay. And let's see what else we've got in the language here. So we've got functions, branch, and as you mentioned here, we've got the advantage of, sort of a dynamic typing. I don't see the types annotated here, but they are inferred. Because we got the strong typing with the trailing return type and the colon and nicely indented syntax. So that looks great. And from our module system here, now with the module system, I imagine we get some benefits too in the compile time. Is Lobster, I mean, when we ran the example, it was basically instant. So can you give any sort of sense of a large project like, from VoxRay Games? Is it compiling, faster than C++ code, faster than other languages at this point, or how's that sort of look?
Yeah, endlessly faster. So so the modules actually don't help with compile time. So they're still brought into the compiler at source level. They're not compiled separately. The compiler compiles the entire program all at once from source. And our game and engine that we're making right now, I'm not sure exactly how many lines of code it is, but it's big. And I just press run within I think it's currently 0.3 seconds because I have timing for it. It takes 0.3 seconds for my compiler to run and libtcc to run. So 0.2 or something like that on a really large code base. So yeah, it's fast.
That's awesome. Yeah, let's see here. All right, let's see what we've got in the language here. Okay, so we've got let, poly, and again, inspiration from Python. This looks like we have some sort of list data structure here. And lists are in the back end, are they truly dynamic arrays or are they linked list data structures? What do they sort of look
dynamic arrays, yeah.
Dynamic arrays.
Okay. No linked lists.
Perfect. Yeah, for speed. Yeah. Now this is interesting here. You've got a float too, and this might have been in our discussion. Is that this is an example of the inline struct that we see here? Perfect.
Yeah. So that's all inline. So this particular array, all the elements of the float twos are just like right next to each other in memory.
Perfect. And then let's see, we've got part of our module here. Okay, so you're defining here with the inline struct again, the parameters for whatever the color is going to be. Your polygon. Let's see. Now you've got, let's see, this is the range here, or for 2 iterations here, I guess.
And so that's what you're seeing here. The reason why this for looks different than, say, Python. I say Python syntax because it largely looks like that, but it's not trying to be exactly like Python. It goes its own way. The thing is that makes that for look exactly like any other function call. So it's basically like the name of the function followed by the arguments, and then the lambda arguments, they follow the closing parenthesis, which is what this is. So this is like as if you're passing a lambda with one argument, namely the I, to a function called for. Now, in this case, for is a built-in bit of functionality. But if you made your own for loop or any other function that takes a function argument, it will look exactly like this. The syntax is uniform.
Very clean, very concise. I mean, this is a piece of code that we write frequently, so that's very powerful. Very cool. Let's see. Okay, so now we're just getting into the line drawing here. Now let's see, what's this guard feature here? I've got n less than max. Is this like an assertion of some sort, or what am I looking at here when I see guard?
It's kind of like an assertion, except it doesn't assert. It just cuts the function short of that particular point. So guard is a specific feature in Lobster. The inspiration for that is that I really like early out programming. So, having a large function, if some binary condition, return this. If some other binary condition, return that. And then comes the body of the code, right? So, but doing that with ifs, you often get into like lots of nested ifs and whatnot. So guard is a way to basically do something similar to an if, but instead of it being indented, it basically is like an assert where it just cuts. Like if this condition doesn't hold, we do not continue this block of code. And unlike an early out, this can also work inside a for loop, say. Like early outs can only work at the top level of a function, whereas guards can work at any level of the function.
Oh, I really like that. There's been a few programming language features as I've looked at different languages. Defer being one that I really love in a lot of different languages, and I think it's picking up. I think this is the first time I've seen guard in the languages that I've looked at least recently. Maybe there's library features or something, but as a keyword. So I think that's really neat and really cool. So yeah, already getting more and more curious about Lobster. So let's see what else we find here. Because okay, let's see. So now we're doing our sort of OpenGL translate scale stuff. Okay, and we've got our math library and some functions built in here. Let's see here. Branch. Now, is that a function? Oh, that is the recursive call here. Okay. So this is building the branches of our Pythagoras tree here. Okay. Now let's see here. Okay, fatal here. Now I should look through. I was going to say I should look through the rest of the program, but this is it. 31 lines
No more.
Here. So this has to be another keyword or a library here, but
that's a library function. It's just helpful for functions like GL window that potentially return an error, like hey, your system doesn't have any OpenGL or something like that. Then fatal is just going to exit the program there with the error.
Got it. Okay. And then let's see here. So I've got this while loop here. So I'm defining my functions here. This is creating our window. And then just trying to parse the sort of execution here. And then we jump into this while loop here, which is effectively our game loop or application loop that's running infinitely. And let's see here. So now just defining some input, clearing things, random number generator, and then generating our branches. Okay, so this seems pretty standard here. Now, normally what I do too is just start messing around and trying to break things here, changing some values. But I'm going to spare us that and maybe look a little bit more at this later. But my first impression again is again, I love this guard feature. That's something I'm stealing or thinking about. The conciseness of the language again is very much matching what a lot of our conversation's been about making things both elegant but very concise, right? Even the range-based loops here. I'm wondering if there's actually another example that comes to mind, if we could maybe just look at one more, because I'm really curious here, and just poke around some features.
I can recommend I believe if you want to see some completely different, there's one that implements a small programming language or compiler, which, because pretty much all these examples are graphical. So a lot of them are going to look quite similar to that pist3.lobster in structure, like a bunch of rendering code, basically. I'm just looking on, there's anything else that's super interesting. Yeah, if you look in sample/demos/ I think it's called simple parser eval.lobster.
Perfect. Yeah.
And
let's
that
take a
also
look.
shows you, because Lobster can be run without a graphics engine attached to it, basically, and be just a traditional programming language. So this is kind of cool because you'll see inheritance, you'll see virtual dispatch, you'll see a whole bunch of like more traditional programming, a little bit more object oriented, if you will, and some parsing and that kind of stuff.
Yeah, perfect. Okay, so yeah, already I'm seeing we've got some sort of interface here. Now this is just a empty class here, I guess. Again, very concise. This is just saying we want things to have a common base class, again in sort of C++, so that everything can be a type of node. That's all we're defining here.
Yeah.
Okay, perfect. And this is as concise as you can get. I love it. There's not even a semicolon here in the language. But that's what you get with the Python syntax, I guess, right? Eliminating these needs here. So very neat. Okay, and then you've got the one-liner functions here. Let's see if we can actually find something. Let me read your comments here. Okay, mini language implementation for a Lispy language. Okay, so parse a string into tokens and directly evaluate and compile to Lobster. Okay, we will actually run this once we're done looking through some of the code here.
That's the dynamic loading that we were talking about earlier. So it actually uses Lobster to execute your own language. So
very cool.
Very cool. Convenient.
Okay, let's see what we've got here. Atom. Now, I've seen this in other languages, again, Erlang, for instance. Now, let me just try to parse here. So these are again, member functions or fields of this class here.
Fields, yeah.
Fields in this language, yep. Okay, so we've got a list of nodes here for our arguments, and then a string here for our atom. Okay, for every instructions, going to be one string, okay. For building up this language. Now this is interesting here. Well, let's start with this first, actually, because usually when I see let in languages, that means we're declaring a new symbol of some sort, but it's immutable. Is that default in here? Okay.
Yeah. So there's both let and var, and let creates a constant, and var a variable that you can change.
Okay. Perfect. And then we're going to take this list here and do a fold operation. Okay, so again, familiar for functional programming for this atom here. But now this part I've got to spend a moment to parse here. This is just a sample string here, I guess. Is that what we're looking at here? Now I've got to, what's going on here?
Okay, so that's actually, so I didn't prepare this to think whether this was going to be a good example to talk to. So it's a little bit overly terse, but I can quickly tell you what's going on here. So first of all, we have a string. The curly brackets are what people call string interpolation in other languages, right? So
yep. Okay.
And so this basically takes two things with a space in between and concatenates them. That's actually all it does.
Got it.
Two things, they start with _a and _e. And that's kind of a weird feature, that this fold function is getting a lambda argument, a function argument, and you could normally specify the names of the argument that it gets, but you actually can write variables with an underscore, and it will declare them automatically for you. So that's an even terser way to writing functions. Okay. And the way that works is that they are going in alphabetical order. So basically, this will get two arguments where the A goes first and the E goes second.
Got it. Okay, very cool. Okay, that makes sense. I can have, in alphabetical order, I can have as many as I want. Okay, very concise here. I love it, though. It's very cool. And then we'll return the elements. Okay. Let's see, again, curly braces in this language here. If I'm returning, okay, this is returning a string here for the type. Okay, got it. Let's see what else is looking interesting here. Okay, so we've got a switch here from our function. I'm trying to think here what languages support this, but I'm able to switch on whatever our input is and just have different cases rather than, I guess you'd write like a ternary function or something, or just have a bunch of ifs and multiple returns. So again, very, very clean here.
Everything is an expression, so yeah.
Perfect. And we've got the same sort of thing here, and with the map reduce, and again, this underscore compile is just taking in, let's see, you got to remind me what the underscore here is doing for the compile.
So that's the argument from map. So map basically says that it's going to take every argument. So every individual argument is going to be underscore. That then gets compiled to its own code.
Mm-hmm.
Then that gets reduced to putting the previous expression, then the atom, which is currently either plus or multiplied, followed by the expression we just compiled.
Mm-hmm.
So again, apologies, this is overly terse, just kind of for fun. You can definitely write this a lot clearer if you wanted to, but
no, this is great though. I think
it shows the power of the language if you wanted to go that far, for sure.
Absolutely. I mean, this is. I mean, I can still read this left to right and understand it nicely, which is very nice here. And I'm seeing again the functional influences. Now let's see. Let's take a look at this here. Assert false here. Okay, that's the default. So this is basically saying if I don't find one of these symbols, I'm just gonna do the assertion or whatever, and I guess terminate at this point.
Yeah. And the special thing is because the compiler knows you're going to terminate there, it will see that actually doesn't return any useful value out of that function. It should return a string, but it allows that because it knows that you can never get past an assert.
Nice. Okay. Very cool. All right. And then if we look through the parser here. Okay, so I've got the functions with inline functions as well being defined here. So again, very concise if we want to do have some of these lambda functions here that are defined. Let's see what we've got here. Note, returning from recursive call. Okay, lookma, no exception handling. Okay, so let's talk a little bit about the error handling story then. Because we've got assertions we've seen. Are exceptions a part of this language in any way? Do we want to write exception handling code? I know as game programmers, we usually don't do it, but is that part of the language here where we're just able to handle like nullables and these types of things? Or yeah, what's the story with error handling?
So there's a funny answer to that because no, exceptions are not part of the language, but you can actually implement exceptions as in user code as a module, which actually, if you look at the modules directory, there's an exception.lobster, which will implement exceptions for you, and you can use them. Why is that? Well, we got this feature that's called non-local returns. So you see that return there, and it says it returns two values, the value nil followed by a string, and at the end it says from parse. So it says do not necessarily return from this current function, which is error, but return from the enclosing function, which is parse. So you can only return from enclosing functions. So why is that useful? It's because if you scroll a little bit down, you'll get the it's going to call error in a bunch of ways, because this parse x function is recursive. So parse x is calling parse x again. And if somewhere down the recursion you call error, then error is very deep down the stack. Yeah, there, for example. But then that error is going to return from parse. So it effectively does what is equivalent to an exception. But it's different from an exception in that you're, rather than throwing an exception, it's like, okay, catch it wherever you want. This returns to a specific point in the program that statically can be verified that it's there. It's also faster. So it's a little bit of a lightweight exception handling mechanism. But like I said, there is exception.lobster, which actually then builds it out to a more general exception mechanism should you want to be able to throw exceptions randomly and catch them wherever you want. That is definitely possible in this language. And in fact, I hate to admit, but that's what we're using in our current game. It actually throws exceptions for resources not being able to load, for example, that can get caught at various places. So, but it's much more of an option. And you can also directly use this from feature to have more control over your exceptions if you want.
Yeah, that's very interesting. I mean, I've spoken to a few other language designers who go back and forth about exceptions, and some of them regret having exceptions in the language because that opens up a whole, sort of can of worms. So it is interesting that you can just load the module if you want that support, like you've done to do some sort of exception handling or lightweight exception handling. That's it's a neat part of the design here, I think. So very interesting.
The reason why this came to be this way is because, like you see other parts of the language, that I wanted to make this idea of being able to pass like lambdas or functions to other functions really, really powerful. The problem is, in pretty much every language that has lambdas, you cannot use return, because if in C++, C#, any of these languages, I write like, say, my own for loop and pass like a body there, and now I want to return from there out of the enclosing function, I cannot do that. I can only do that with the built-in for loop. I can do that. I can escape out of the for loop. But if you make your own for loop with a lambda, now you can't do it. So the purpose of this language was make those lambdas just as powerful as built-in bodies of code. So now you can escape out of like a higher order function or anything like that. Generally, I think it's important that you have like a higher order function or recursion or anything like that, that you're able to basically cut the evaluation short. Not even just for errors, like there is basically, I found the answer, or there is some other reason why you want to stop recursing and iterating. And that should be possible in any context. And most languages, funnily, don't allow that, which is kind of weird.
Yeah, I guess you have to have some sort of clunky mechanism in C and C++ of breaking and passing state around or something to get an early out.
I've actually had it in C++ code where I detect an error inside what's block of code. It's inside a lambda, and now I'm like, okay, I need to somehow encode this error in the return value of this lambda function. Make sure that the function that calls the lambda function somehow parses it out and passes it back onward. It's a total mess. Or use an exception. But yeah, those also have downsides. So
right. All right. Well, let's see here. We've got some test code here. Let me actually, and we've reached the bottom. Let's actually run this code here, because as you mentioned, it's going to compile to Lobster. Let's give it a try here. Let's see here. We've got here. So let's see what happens here. So I'm going to run this. We've got our AST pre-printed, and it's evaluating this. So let's see if we sort of do 2 times 3 times 4 and then add 10, 34. So the answer is correct if we go through that. And then it's building this tree for us. Okay, very cool. And again, giving us the correctly compiled result here. Yeah, this is a really fun example actually to stare at and think about how I'd refactor it in the way that I think and then in the way that Lobster does. That's actually very powerful sometimes going through that. I know you said it was concise code, and it truly is, which is really cool. So very expressive. Wow. Okay. So that was fun to give like a mini preview of the language here. And there's all sorts of cool examples here. I mean, I'm seeing stuff with shaders and cool graphics effects and physics and so on that I think folks should probably dive into and play around with. But I want to sort of wrap us up, since you've been very generous with your time and I know are very busy running a studio and a company and so on. So if I may, I have a few rapid fire questions for you, if that's okay.
Bring them on.
All right. So first and foremost, during our conversation, I wanted to ask you, I mean, do you consider yourself a hacker in the most well-meaning of terms, someone who likes to think about bits and bytes and really organizing things? Is it fair to call you a hacker?
I would say in the original meaning of that word, absolutely, yeah. And I'm certainly old enough that I come from the times when the word hacker was still associated with that meaning. So
yeah.
Absolutely, yeah.
I always think of it that way too. So for folks who also want to be hackers, what's a programming book or article or video? What's something that everyone aspiring to be a good software developer should read or take a look at?
There's so many good books. It's a difficult question. One that comes to mind that I've recommended before for people that are struggling with like, hey, I want to be more of a, hacker, bits and bytes person, understanding the machine deeply, but I've just come through a school that only taught me Java kind of thing, is this book called Memory as a Programming Model. And it takes you through C, but it talks a lot about memory and stack frames and a lot of like low-level stuff that basically is like shows you under the hood of what's under a programming language, giving you a very deep understanding of. So it gives that what we were talking about earlier in terms of how to build up your programming knowledge. It all kind of makes sense together. This is a kind of book that you can either start with or will attempt to fix whatever lack of understanding of the low-level stuff you may have missed in your previous career. So I really like that book.
Do you have right now a favorite game or piece of electronic art or something that makes you go wow, or has made you go wow in the past?
Oh gosh, that is such a general question. There is so much amazing stuff out there. I guess I'll answer game. I have a lot of favorite games. I will say a game like Valheim has really surprised me in terms of like how amazing it can be. It really has such fantastic atmosphere. It really gives you super special feeling playing that with your friends. It's a very inspiring game that I think is really rather special. That's just to pick one out. I have a ton of games I like, but shout out to Valheim, I guess.
And any last advice to aspiring programmers, folks just getting started, or words of encouragement or wisdom you can pass along?
Oh, that's another topic by itself. People just getting started. To me, the biggest thing whenever I talk to anyone about like maybe they want to, get into programming or not, I feel always you need to find out whether the very active programming is something that energizes you and motivates you, or whether it frustrates you. Programming contains lots of things like debugging and testing and whatnot. If you're stuck debugging something for an hour or several hours, it's never fun. I mean, it's not fun for me either. But are you able to get through there, learn something, and then are energized to do better next time? If yes, you might be a programmer. If that stuff just keeps frustrating you to where you want to throw your keyboard at the wall, then it might not be for you, kind of thing. That's what I would look at. I would try to see if you can find pleasure in just like the actual core of programming, rather than trying to just get to some kind of end result. If you're always worried about just getting to the end result, you'll probably struggle as a programmer long term.
Yeah, well, it's been a real pleasure talking with you, Wouter. And like has been mentioned, we could have many, many more conversations on all these topics for many more hours, I think. But I just want to thank you for your time. I'm going to link to your website, sterlen.com, very easy to remember, and the Lobster Programming Language. But I want to give you a moment. Anything you want to shout out that you're excited about? The stage is yours for the last word.
Of course, I have to plug the game I'm currently working on. So, if you're interested in things like, wow, this guy might be making a cool game, go check the game VoxLands on Steam. Give it a wish list if you like. Other than that, I hope you'll try out Lobster. We have a Discord. Come join and ask questions and see if you like it. So.
Well, excellent. Well, thank you again for your time, and thank you for our audience to listening, and we'll look forward to seeing more of your languages, games, and more in the future.
Thank you, Mike. It was great talking to you. I'll see you later.